We have here a U-shaped permanent magnet with the North Pole and South Pole being labeled. Let us confirm that the labeling of the poles are correct. We shall use a bar magnet. This is the South Pole labeled S and the North Pole, red in color, labeled N. When you hold the South Pole of this bar magnet next to the South Pole of the U-shaped magnet, you can feel the repulsion. If you let go, you can see that it is repelled and attracted to the North Pole. If I were to hold the North Pole of the bar magnet next to the North Pole of the U-shaped magnet and I let go, immediately you can see it is repelled by the North Pole and attracted to the South Pole. This confirms that the labeling on the U-shaped permanent magnet is correct. The setup of this apparatus is similar to the diagram in page 157 of the Form 5 KSSM Physics textbook. We have a copper wire placed in between the poles of a U-shaped permanent magnet. The copper wire will be moved upwards so that a current is induced in the wire and a galvanometer is used to detect the current. So we shall move the wire upwards. Look at the galvanometer. When the copper wire is moved upwards, we can hardly see any deflection on the galvanometer. Is it because there is no current induced in the copper wire? The induced current in this copper wire is very small, and this galvanometer is not sensitive enough to detect the current. The galvanometer that was not sensitive enough to detect the small induced current in the copper wire can still be used. We will replace the copper wire with a copper coil of more than 20 turns. Current can flow through this copper coil this way or the other way around. So this copper coil has a side that consists of more than 20 straight copper wires. If you place the copper coil in between the poles of the permanent magnet, here we have straight copper wires, more than 20 of them, and if any current is induced in the wires, the induced current is multiplied more than 20 times, and then it is large enough to be detected by the galvanometer. We have a copper wire placed in between the poles of a permanent magnet. This is the North Pole and the South Pole. The wire is connected to a galvanometer, and the wire will be moved in the upward direction. According to Fleming's right-hand rule for electromagnetic induction, the forefinger shows the field from north to south. The thumb will indicate the direction of motion upwards. Motion is upwards, and therefore the induced current will flow in the wire in this direction, which means the induced current will flow into the galvanometer at the negative terminal this way. And let's see what is the deflection of the pointer of the galvanometer. So the copper wire is moved upwards. Notice the pointer deflects to the left or a negative reading. We shall repeat. The wire is moved upwards. And it is very clear that for this galvanometer, the pointer deflects to the left, showing a negative reading.